Welcome, everybody. We are in a very chilly morning here in the Northeast, 2 weeks before Christmas, but welcome to all of you who called in, and welcome to my friends on this panel. My name is Lee Silvestre. I have been involved, just to jump in with 2 feet here, I've been involved at the intersection of defense and blue tech and commercial space for many years. My background is in applied math, ops research, and engineering. And it's led me to roles spanning defense consulting with KPMG Pete Marwick, technology applications with Raytheon's integrated defense systems, launched a new company, Enlightened Color. I stood up the Undersea Technology Innovation Consortium and secured the OTA with the Navy. And then most recently, Naval X Director of the North Atlantic Tech Hub. Very, very recently, within the last couple of weeks, I finally had the courage to leave the role with the Navy and strike out on my own in an independent advisory practice working with blue tech industry and dual use applications, doing more of what I'm doing, but for the general ecosystem in the maritime space, spanning defense and commercial markets, called Venture Frontiers. So great to connect with all of you virtually. Getting into the topic, we are in a world with lots and lots of information, excessive data feeds. It results in a lot of signaling and noise as we try to address situations requiring key decisions and, of course, more importantly, actions. Very true in the maritime space, both manned and unmanned applications where, as an example, navigation sensors are collecting and amassing significant amounts of data. Why do we care? Why is this important? Well, it's the difference between available data versus data allowing situational awareness that leads to impactful decision making. Today, we're addressing how we harness navigational data and best turn it into situational awareness and feeds for meaningful decisions and actions. What missions, you might ask? It could be missions involving safety, navigation, threat detection, or a number of others. Data, more importantly, the right data at the right time can enable key decisions. Along with plenty of data, we have the role of artificial intelligence and machine learning to help turn data into meaningful insights. Today, we'll discuss our unprecedented ability to capture and bring together data, both opportunities for benefits and, conversely, the challenges we face with that. We'll address decision-making, whether by humans or machines, including tools and processes that rely on information. So together, we brought together 4 very impressive leaders in this space from 4 great companies. And I'd like to start with an introduction to each of the companies, and then I'll introduce you to each of the speakers. We'll get into the topic. So in no particular order, SEA.AI. SEA.AI uses the latest camera technology along with AI to alert crews early and reliably about objects on the surface of the water. They detect and classify objects, including those that escape conventional systems. They compute input from low light and thermal onboard cameras to paint a digital landscape of the vessel's surroundings. SEA.AI. Second company, Robosys Automation. Robosys develops and deploys AI-powered, now this is a mouthful, maritime autonomy and smart shipping software. It's called Voyager AI. Their software transforms new build and existing vessels into fully autonomous vessels capable of independent navigation and autonomous collision with obstacle avoidance and anti-grounding with dynamic route optimization. In addition, their collision avoidance systems provides advice on collision prevention rules, and for those of you part of the maritime world, coal regs, to ships' captains and bridge watchkeepers. Third company is OSI Maritime Systems. They're a Canadian defense technology company that provide integrated navigation and tactical solutions for naval and maritime security operations. They are headquartered up in British Columbia, and they focus on warships, submarines, small craft, supplying systems to roughly 25 NATO and allied navies, operating about 700 vessels worldwide. The company is a pioneer of what they have coined the Warship Electronic Chart Display and Information System, even more interesting acronym, that integrates electronic charts with data from ship sensors to provide precise navigational and situational awareness, including collision avoidance and tactical tools. They deliver integrated navigational and tactical systems for surface combatants, tactical dive navigation system for submarines, C2 navigation solutions for small craft and maritime forces, along with training and through life support. Last but not least, FarSounder. FarSounder produces 3D forward-looking sonars that reliably detect in-water obstacles and shallows. Their products can be used in a variety of applications for obstacle avoidance and shallow water navigation, designed to fit many types of vessels, and you hear dual use in this, including yachts and cruise ships, research vessels, and defense and government needs. They also provide services to fisheries and small commercial vessels. So that's an overview of the four companies. Now, I'd like to embellish about a little bit of the background of each of our speakers and get into the topics. So, again, in no particular order, but the order I started with the companies. Philipp Stampfl, Head of Products for SEA.AI. Philipp just raised his, there we go. Philipp hey, Philipp. He holds a master's degree in mechanical engineering from the Technical University of Munich. He's sailed his whole life and has a strong focus on dinghy and offshore racing, and has worked part-time as a professional sailing skipper in Europe and the Caribbean. Before joining CAI, Philipp gained experience both in small startups in Munich in a large world-leading Australian steel and technology group, and he contributed to a major project for a new steel plant. All of this came together as a friend told him about a new startup in Austria developing AI-based camera systems for sailing vessels, perfectly combining, the light went off, his professional skills with his passion for boating. He brought the whole thing together and joined CAI, formerly Oscar Systems, almost 6 years ago now. He initially took on multiple responsibilities as with many startups, small product owner, overseeing production, supply chain. But with the company's success and they started growing, he shifted his focus entirely to product management and now leads both product and project management. Thank you, Philipp, for joining us. Next, we'll move on to Nigel Lee. He's the Chief Strategy Officer for Robosys Automation. Hey, Nigel. Nigel brings 18 years of global defense, maritime, and commercial sales experience with a bunch of companies, Lockheed Martin, Ultra Electronics, and a U.S. private equity-owned engineering company. Previously, Nigel served in the Royal Navy for 23 years as both an engineer and a seaman warfare officer and master mariner on both ships and submarines. He's been around the block a little bit with some great experience. Throughout his military and commercial career, he's been extensively connected with the sea, from service in submarines and ships, including maritime autonomy for unmanned vessels and ships for the last 10 years. He's a council member of the UK's Society of Maritime Industries, called SMI, Maritime Autonomous Systems Group. And in June of 25 of this year, he was awarded SMI's Marine Science and Technology Business Person of the Year. So congratulations, Nigel. Okay, next we'll move on to Nancy Setchell. She is the Autonomous Capability Development Manager for OSI Maritime Systems. Nancy, love your sweater. Very nice. Private joke, we'll move on. She is a retired commander, enrolled in the Canadian Armed Forces as a naval warfare officer. She's completed her initial education and training, specializing in navigation, becoming a fleet navigation instructor. She served on the East Coast as a weapons officer and executive officer. In 2018, she was appointed as commanding officer, HMCS Charlottetown. She's held some pretty big positions. She was the second woman in Canada to hold this position, and she enjoyed her time as a leader in this role. She holds a Bachelor of Art and Masters of Defense Studies from the Royal Military College of Canada, and a certificate in diversity, equity, inclusion from Cornell University. In January last year, 2024, she was pleased to join OSI Maritime Systems, where she is, as I mentioned, the Autonomous Capability Development Manager. And she actually, in her own professional career, used OSI's electronic chart integrated navigation system for 25 years and was a big fan. So she's an evangelist for the company, and now she looks forward to helping them chart their course for the future. So again, last but certainly not least, is the CEO of FarSounder, Matt Zimmerman. Hello, Matt. He founded the company more than 24 years ago. He had to be 3 years old at the time, by the way. Matt is very youthful looking. Since its inception, he has driven the technical development and vision of FarSounder. His focus is on growing the company's reach and developing an expert design and implementation team capable of translating customer needs into best-in-class commercial products. Whether for use on manned or unmanned vessels, he leads his team with a passion for marine safety, for the stability of the ocean ecosystems. With these goals in mind, he leads FarSounder team in an effort to create safer oceans through participation in the International Hydrographic Organization's crowdsourced bathymetry working group. So welcome, Matt. Okay, with that, we have a number of questions, and what I'm going to do is I'm going to pick somebody on this panel to start off with the initial answer, and then we'll give the rest of the panelists a chance to opine. So for the first topic, today's unprecedented ability to capture and bring together data presents certain downfalls, pitfalls of too much data and disparate feeds. Nancy, can you kick this off for us?
Yeah, I love this one because it's, we how do we know that this data is any good, that any of it's any good? And, there's a real human reluctance to take in, a feed that maybe doesn't agree with the others. And I find that's, with technology or even it's with other humans, that there's all that friction that sort of happens there. And we have to be able to understand what data is good data, not good data, and also sometimes be a little bit humble to understand that computers don't have bad days. They don't have a bad sleep. They don't miss their coffee. That humans are in fact capable of human error. And we know that human error accounts for so many whether it's a collision at sea, whether it's whatever it is, that human error is very much a part of it. And how are we going to integrate those other views that come in by being absolutely overwhelmed with information? So it's a little bit like I saw this happen when we went from paper charts to having a fix that was 6 minutes old, and then you DR or EP around the corner and you get that, and then and then we went from having this basically what some people could call a God's eye view of information, but maybe that's overwhelming. We don't trust it. It's certainly, that's a fad. It's not going to work. So how do we understand it to the point that we can trust it? I think is really the big challenge.
I think integration really is also a pretty broad term. So if we step back a moment, for different people, different systems, integration can have a lot of different meanings. So it could be as simple as there's just a KVM switch with multiple sensors showing up on different screens. Of course, that's hard to handle multiple data streams if you have more data streams than displays that you want to use. You mentioned this combined display a moment ago, Nancy, and I'm a big fan of getting relevant information into one interface for the operator, whether that's a machine or a person or a combination of the two. For example, in our software, we make forward-looking sonar systems, and that is our primary value proposition. But our display uses chart and aerial imagery as an underlay. We have AIS and ARPA. We now have targets from SEA.AI to provide that unified picture for the operators. But doing that in a way that is intuitive and easy to use is also a challenge. And I'm sure, Nancy, OSI has even greater challenges because you're not just the current situational awareness, it's also the planning and the weapon systems integration and the fleets. So it's a really complicated question, and doing that well is really critical for whatever the system is.
And I think also making sure that people will accept it, that you're not just throwing another rock in the backpack of the person who's right at the front edge of it.
Yeah, They need to be
Matt,
complementary.
you mentioned integration, right? And I mean, there's one way of overlaying information, and I think it's great that now also CI is part of the FarSounder application. But another terms where at least we as CI is working on is really fusing the data, and not only having overlay, which is great, but fusing also brings another complexity, because then you need to be sure, okay, which value are you, or which data stream are you trusting? Because more data is not always helpful. I mean, also we haven't talked about alarms. Also in terms of alarm fatigueness, this is a big problem, and what leads to that people just turn off great tools they have. So how we let's say show data to the users, or later also to machines and other navigation software, let's say, is critical.
Nigel, you're on mute.
If I can pick up on 3 of the points there, integration, first of all, what standards, what format is the data? So we've touched on dual use, there's commercial, recreational fits, and there's military, and they've got different standards, different data sets. So that's one of the challenges as well. And the other one is where to bring the data. Because there's autonomous platforms now, you can bring the data to and sort and filter, manage the data on the vessel, or it can just be received at the vessel and then stored in the or sorted in the cloud or ashore. So that's the other question of where do we bring the data together, which lends into Philipp's point about fusing the data. I'll just leave it because we're in a discussion here, and there's other points, is to fuse or not to fuse. Because are you fusing good data or bad data? Maybe you should keep them apart and use all source for decision making, or should you fuse them together? So I think that's the 3 good discussion points that have come out of the first question there.
Yeah, even with redundancy data, right? I mean, let's say if you have multiple GPS sensors and you go under a bridge, you need to know which one to trust. And if failure of sensors is also an issue. So I can really relate what you said, Nigel.
One thing I learned in defense is sometimes plentiful data and good data fusion and data integration creates more data. And it is a funny cycle you get into, because at some point you have to turn that obviously into something that gives you insight, something that leads to decisions. So while this whole discussion has migrated to this next topic, the next topic was formally the difference between capturing and harnessing data and meaningful data integration. Again, we've been talking about that all along as a natural progression of the first thing. Matt, is there anything in addition that you'd like to say about that topic?
Absolutely. So as I alluded to before, our display uses multiple data sets. As Philipp alluded to, it's not just displaying the information, but how to use it together. I think there's really some goals. Like you said, data begets data. We don't want to just make more and more noise. And I know we're talking about high-tech things, but one of the stories that I am continually shocked by is talking to senior bridge crew, where they need to remind the junior crew, your most primary sensor is your eyes. So, we need to make sure that we keep it simple how we integrate this information together. Obviously, on the uncrewed platforms, we don't have eyes on the vessel. So we need to produce that artificial eye back in the control station for the human in the loop. And then obviously have the correct prescription for those eyes going into any automated control system. So what can we do to remove clutter? That could be when we have multiple sensors in multiple domains. When they agree, there's a high probability that's not clutter. When they don't agree, there's a lower probability that is not clutter. If we can fuse that information, like Philipp mentioned, together, then it's not just your brain making those correlations, but it's also the machine aids, whether it's a decision support system or fully autonomous. So I'm excited about how to do that well, because if you're not doing it well, then you really need to revert back to only your eyes. And all of us here in this group certainly believe we can do that well with our products and technologies.
If I just follow that point, we need to define because you have a range of attendees on the audience from recreational, commercial, defence, etc. And all of those could go from 5 metre to 300 metres, which means the navigational sensor will have a higher degree of accuracy for the larger vessel, more expensive, more data, more reliable data, and the smaller vessels might not have the same level of capability, but it's all about the size of the platform, the risk, the kinetic, danger of operating a vessel. So I think size comes into play, and therefore, I assume we can have better data from larger platforms with higher grade sensors.
Yeah, and even depending on the sensor, like optical sensors can see over water and can see very small objects which cannot be detected or hardly be detected by radar. But cameras cannot see through water. So therefore, a forward-looking sonar comes into play. And fusing all this data gives us a better situational awareness, let's say, even 360 degree situational awareness with radar and panning cameras and forward-looking sonar, maybe even microphones. And I think in the end, also when it comes to using the data for autonomous vessels, but even for crewed vessels, therefore we just need to use all sensors, but we also need to know the limitations of the sensors. But combining them in that case can really boost each other and compensate for limitations.
Yeah, in the ideal world, they're complementary so that you can fill the weakness of one sensor domain with the strengths of another, but also overlapping, like we said, to increase confidence. And that's, in my mind, one of the challenges of an integrated solution. How do you put together this top-level summary for the human or the machine operator, but also how do you display uncertainty? And when there is something that doesn't make sense, how can you revert back to subsystems or fundamental components to identify where are the problems? And we're seeing that a lot today with not just GPS jamming, but also GPS spoofing. Jamming is sort of easy to understand. If your cargo ship is showing up at the Egyptian airport, you know that that is not correct. Or if you have no GPS lock and you're not getting position, you know that's not reliable. But when you think your GPS is giving you a position that's been slowly adjusted over time, and you are now nowhere where you thought you were, what can you do to roll back to a less integrated solution or downgrade the priority of one of those sensors? And how do you identify even these problems and faults? Those are all challenges that we as an industry really need to look at in a holistic approach, I think.
Also, I think with using more data, with using more data, you rely on more other sensors. Like there are so many products relying on GPS, and I think now in these times, even it's not only in the security world, it's also now in the recreational world. People understand, okay, I cannot rely on GPS, and there are so many products built on GPS, and they are not working without GPS anymore. So I think this is now really a problem, also for recreational world, not only for the security and defense world.
So this conversation is interesting because I heard us get into dimensions of goodness, dimensions of wellness, and I heard things like timeliness, accuracy, reliability, complexity, or simplicity, both true, uncertainty, all leading to various, again, dimensions or characteristics of value. So if we move on, another topic is, and again, we've touched upon this because of the rich discussion and the participation, but the challenges of turning collective data into knowledge and insight, and some of those challenges and risks that it proposes, also opportunities that maybe exist and have yet to be realized. Philipp, you have some great insight here. Can you take that one first?
Yeah, sure. Thank you. So first of all, on a boat, on a vessel, what are you, as an operator, what are you doing with the data? In the end, it's about taking a decision or taking any action. That's the important part. And over the time, I think most of the sensors we do have on boats, is it a radar, is it the sonar, or nowadays it's even cameras and something. and AIS and whatever is on the vessels, it's designed to help the operators, to help the human to take decisions. And I really believe now in a world where it goes more into autonomous vessels and something, we also need to have sensors which more or less replace human sensors. Because Matt already said it, I mean, the best sensor from the operators is the eyes. So now we need artificial eyes, which is camera with artificial intelligence, which not replacing a human, but it can replace a human when it comes to fully autonomous sensor. So there, that's why I really think also AI is mimicking or is like acting as a human, even if it's an artificial human, and therefore we also need to have sensors on board which replaces human sensors like ears and eyes. And even I give you a simple example. When you are on a fast trip and you feel there is, it gets uncomfy because of rough waves, you immediately lower the speed. You do that automatically. So also you need something like IMUs that you know on a uncrewed vessels, hey, maybe I'm too fast, otherwise everything will break. So these are one of the new challenges to use data and then transfer this data into a knowledge that you can or an operator can take decision, and therefore obviously if the AI is helping an operator, that the operator can concentrate on other tasks he has to do, or in the world of let's say unmanned remote USVs or ASVs, that the computer or the AI is really taking the decisions on its own.
Yeah, so I picked up on your point about the best is the eyes, and as you're a speaker, you know, yourself, myself, Nancy and I are watchkeepers, etc. It's also, as you said, the hearing, because there's the sound signals. We're now putting autonomy onto vessels, and therefore the concept of operations is now changing. What can you do with an autonomous vessel? So now maybe increasing sea state. So the other, you know, as you talked about, the balance, having our own, we've got our balance in our nervous system. We've got this sound for sound signals in bad weather, restricted visibility, and the eyes as well. And actually, as we go from uncrewed to optionally uncrewed to fully autonomous, we're having to bring in a whole array of extra sensors and data sources, not just as in target contacts of interest shipping, but also the navigational aspects, which Matt, you talked about, is GPS, GNSS, maybe bring in IMUs, Doppler velocity logs, all of that to help. You know, the challenge is becoming greater the more we build trust into autonomous operations, autonomous platforms.
I think your comment about trust is really interesting. I'm sure we've all used or interacted with someone using ChatGPT where it spits out total nonsense. And so, you know, from my experience, it's really good for some things, but we can't just unleash it on its own. We see similar things with self-driving cars. You know, in some conditions it works really well, but then it just drives directly into the back of the parked tractor trailer. And I don't want to debate whether these incidents were better or worse of risk compared to person versus machine, but there's clearly this theme of I know how to trust myself. Nigel, you know how to trust yourself based from your past experiences. Maybe I trust you, Nigel, because I know you well. Maybe I don't trust someone else because I don't know them well. But how do we trust the algorithms taking over in those cases?
So if I may say a couple of lines, and I'm going to let Nancy maybe pick up on this. But I think when we talk autonomy, it's all about the absolute. We expect the autonomous navigation to be 100%. But as humans, we differ. So our Voyager AI software is in bridge simulators to be tested, and they set the machine with a CPA and a time to CPA slightly different, because I presume I'm older than you, Matt, so I'm going to be slightly more risk adverse and slightly slower. It'll be much sharper, and therefore the CPA will be tied to the time to CPA. And that's about building trust. But the point is, we all seem to be demanding 100% of autonomous operations, but we as humans make mistakes. Nancy, you've just done some sea trials last couple of weeks, haven't you?
Yeah, I've been out to sea and I've watched people, you know, make watching people make decisions, under, I get super seasick. So, and it doesn't seem right, but I get super seasick and I take medicine for it and I'm fine. Makes me a little bit tired, but I still make better decisions when I don't want to throw myself over the side from seasickness. So, but you see people, making decisions and in accordance with collision regulations or not in accordance with it. And you think, well, maybe a machine would make this better, or a machine would always make this decision. But I think we also have to consider that crewed and uncrewed systems are going to be operating together for a very long time. We're not all of a sudden going to be going to uncrewed systems all the time because we don't need people at sea. We are going to have these operating, and so what are the rules for interactions between those two? And what are the sort of, I don't want to say social norms, because they're not social norms. They're norms between vessels, right? When you see that people should be operating the same way they are, and you look at the construct of that, the call rigs, and how that has evolved over time, and it's always we went from having sailing vessels to steam to radar to enhanced navigation, and how is that going to change along the way? So I don't think that construct has quite caught up with crewed and uncrewed vessels. But mariners, I find, tend to be pretty untrustworthy of other mariners, right? You start off, you're just like, I don't trust that guy. I don't think that they're going to do the right thing. And amongst those, I think like submariners, people that navigate under the water, are particularly untrustworthy. But they have developed over time because they operate without GNSS. They, find a way to operate for months at a time under the ocean, and now we see a lot of our customers. They want that technology to creep up to the bridge again. So surface navigators are using subsurface technology, so almost reverting back to something without GNSS, without that. So I think the construct of what we expect of humans and uncrewed systems, that's going to have to change. The collision regulations are going to have to change to anticipate that. But also, we have to go back to being untrustworthy as bridge watchkeepers and understand that, I hate to say it, but computers are more reliable than people.
So Nancy, as you're describing this, I look in some of the comments, and I will apologize up front. Can't keep track of all the comments necessarily, so I apologize if I miss somebody's. But Derek Niles mentions that once you mentioned single sources of information run ships aground. And he talks about fusion versus separation of data sources for cross-checking and validation being key. So I think this conversation we're having all lends itself, and points you were making, Matt, earlier. Jagannathan Longachari mentions that he draws the analogy with the ADS systems in the automotive world. Well, you can read it there, and adopting some of these techniques that we're just now getting used to in the automotive world, but doing it in a way that we can develop a sense of reliable trust, and that's tough.
It is. I think that's, and I'll just pick up on this. So I have a daughter who's just turned 16, and so I take her out to drive in our Honda CR-V, which we think is a very safe vehicle. It's got lane drifting. It's got like the little beep if you're getting too close to someone, and I think about how that is so different from the vehicle that I learned how to drive in, that you had to like roll the windows down yourself. And we've just so subtly come to have all of these things that are helping people drive that I believe it is inherently safer, but I don't know that it's going to be safe enough, because that's my kid out there, and what the other drivers are doing, and all of those things. It's those same feelings that we just have to acknowledge, that human side of not wanting to adopt the technology.
I would love to go back, lead a comment you brought up from Derek's post in the chat. Mm-hmm. Single sensors or single data sources run vessels aground. I think this is even more critical in the uncrewed or autonomous world. I obviously have a close affinity with depth information coming from my company's background. And one of the things that I think is astonishing is we have only surveyed about 50% of coastal areas worldwide. And as autonomy is moving from highly curated surveyed areas and deep water areas into littoral missions, whether it's bringing crew, whether it's bringing cargo, whether it's wayfinding, whatever it might be, you can't rely on the chart as being a source of truth. And human operators, they have tricks. If the sun is in the right angle and the water's clear, you can post a watch visually looking into the water. You can look for the ripples at the surface. If the water is calm, that might indicate an upwelling, then maybe there's a reef there. You can look for the stationary small white caps, that are implying there might be a subsurface obstacle causing some waves to break. How do we translate that into the uncrewed and even the autonomous operations? That's a challenge. So I don't think we can rely just on the old techniques either.
Can I pick up on that? And there's a comment from Ansel Rodolph asking about best practices for integrating multiple sensors, GPS, INS, LiDAR. Let's put forward-looking sonar in there. I think, again, I touched on the fact that we have a range of size of vessels in the audience, from perhaps 6 meters up to 300 plus meters. We also have a range of operating areas, from harbours and ports, coastal, so let's call that green water, and open ocean, let's call that blue water. So to Ansel's question about best practices, it depends on the operating area and the size of the vessel. To your point, Matt, about chart data, there is obviously scoring on the chart of the accuracy of the data. What we're finding at Robosys is when we're going into that green to brown water, the coastal, is how can the software, how can the automation navigate safely? So having enough of a sense, like a forward-looking sonar, produces an object at range to make decisions in advance, so be proactive, as opposed to an echo sounder where your depth is there now. And to Ansel's question about LiDAR, very short range, ideal for berth and unberthing, etc. In the open ocean, too short range, that's 100 to 200 meters. That's where the SEA.AI or perception system comes in with a longer range. Depends on the height of eye. A 6 meter vessel will only have a short range. A 300 meter tanker are much higher, and therefore more range, more accuracy as well. So
and that's analogous to crewed vessels. If you think about coming into the dock, if you're on a small 6-pack fishing charter, the captain's going to say, "Everybody sit down so I can look out the back window or check the stern as we're approaching." If you're on a larger vessel, you might have a steering station facing a stern behind the main wheelhouse, so you get a better view. So it's using the person's eyes, but it's almost like different sensors for different applications and different parts of the overall vessel's journey and mission.
Yeah. I would add, too, coming from a state with the largest percentage of coastal area, Rhode Island, in addition to the naval North Atlantic coastline that we're looking at, everything from energy harvesting to fishing, seabed to surface farming, structural reinforcement, things like that change constantly our littoral picture. So just because we have a data feed, it matters. Is it timely? When was it updated? Is it integrated with other things? Much less the changing dynamic that happens as we get everything from passive to aggressive infiltration of swimmers, divers, sensors, techniques, all worthy of keeping track of and figuring out how it affects your scenario.
Yeah, I recently had a conversation with Anthony Clem at NOAA. He's doing a lot of work for NOAA on crowdsourcing data. And he was comparing some crowdsourced bathymetry that one of our users contributed through US East Coast waters. These are areas that are considered some of the best charts in the world, some of the most accurate charts in the world. And the data that we got from the crowdsourced bathymetry totally contradicted what is the official NOAA data there. And so he took a look at some of the satellite drive bathymetry, which has, again, strengths and weaknesses. That also totally found discrepancies with the NOAA official data. But the crowdsourced data and the satellite drive bathymetry correlated. And so for him, this was a big red flag. Here's a spot that we need to look at again. So it's, this was off vessel, but you can't always assume that even your reliable historic data is valuable. So it's, it all goes back to the don't trust.
And I think that's how we started this topic. I mean, in the end, as a human operator, you do so many, let's call it sanity checks on your own automatically. You don't even think about it. And when it comes to more automated or semi-automated things, we need to. Or it's a big challenge to really make sure, okay, this data is trustworthy and this data is not trustworthy. And I think at least something we at SEA always concentrated to be not rely on other sensors, to only rely on our eyes, let's say, and be really good at what we are doing, and not fusing the data which helps us first. So really just make sure that our data is accurate, that later we can fuse it with other data and together with Robosys or with FarSounder to get a clear picture. I think that's important.
So I'm just looking at the questions here. There's one from Stephen Bryan, who's playing on my heartstrings as a former submariner as well. He's asking a question about weighting, really, the data. And I think that raises a good point. We've been talking about situational awareness, I think, as in we're getting data from different sensors. It's the decision making. So to answer Stephen's point with autonomous navigation, we can weight the sensor because we may have more trust in one than the other. And that is in development. That the adoption of autonomous systems has rapidly expanded over the last 3 years, obviously, given the geopolitical situation. And now the ability to weight them differently as we perhaps go from the blue water, open ocean, green water, coastal, brown water, littoral, means we may have to put more onus on a forward-looking sonar as we get towards the land, whereas in the open ocean, just think of some of the other questions that have appeared there, more trust maybe in the radar in the open ocean, GPS, because we're not going to be jammed. So again, it comes back to the concept of operations. Are you in shallow water? Are you in deep water? Are you close to land? What size vessel are you? What is your mission, Lee, as you introduced? Are we doing safety? Are we doing ISR? Are we perhaps going on a one-way mission, never to come back again? I think that will change the weight of the data and what is important.
It gets into the right data at the right time topic. So this is a rich discussion that can continue for many hours, I'm sure, and I would love to entertain it. So let's evolve this, though. Even though we have hit upon this in pieces, let's hit upon the topic of decision-making tools and processes that rely on information, as well as the role of AI bringing together data and processing it. Again, we've hit upon it, but your thoughts specifically on that topic. Nigel, can you kick that off, please?
So AI is a massive subject. So and there's also it's the latest buzzword, it's the latest investment area, but what does it mean? And I think there's a misconception because AI can mean many things. It does mean many things because within AI, perception algorithms is one part, but machine learning is another part. Within machine learning, where's my bubble diagram? You've got different decision trees, etc. And then neural networks and deep learning and generative AI is right at the heart core. So AI means many different things. Technically, academically, it is many different things, and it's just an all-encapsulating word. I mean, if I come back to perhaps the Voyager system that we have within AI, there's ML, there's decision trees, etc. For us, working to build trust, that Matt and I have talked about earlier, We're working with Australian Maritime College, where I've been in their simulator for 3 years, where they're putting STCW watchkeepers into 40-meter, 200-meter, 300-meter tankers at 45 knots, human versus machine, machine versus machine, to build up trust and understand what happens in the situation. Now, given we're talking about sensors and navigation agents in a simulated environment, so it's just an AIS simulation. But the point is, they are building trust. You need to build trust in AI. AI is also it's about a big data problem. This is what we've got here. We've got more high power computing has come along, and in the last probably the last 10 to 5 years, high power computing has allowed the algorithms to happen to provide so much data. Now we've got a big data problem, and AI is allowing us to sort that. But again, I come back within AI that is multifaceted. And then it also comes back to I keep saying concept of operations, but we've talked about crewed and uncrewed being autonomous, but there's different levels within that, because actually uncrewed doesn't mean it's autonomous. It means there might be some in the remote operations center. So there's levels of autonomy from 1 to 4, and AI can play different roles within that. So Nancy, your ECPIN's CADA product is a decision aid for crewed vessels, whereas Voyage AI is extensively used to drive autonomously the vessel. So I don't know, Nancy, if you want to pick up on your collision avoidance decision aid CADA piece.
Yeah, and because it is important that we're able to sort of use AI and use this like fantastic tool that we have. But again, it comes back to how are you going to train people on how to use it? Because we're really coming into this, is it the next industrial revolution, right? The information age, and beyond that, which is it's artificial intelligence, and it's every facet of the maritime world at this point in time is going to be affected by it. We have charts, the S100 charts that are coming in that are going to have, you're going to be able to see the tide goes up, tide goes down, tide goes sideways, tide goes other way sideways, and how do you not get absolutely overwhelmed by all of that? And I always figure that I've spent a lot of time on the bridge, and I've watched bridge watchkeepers. I've had, have bad watches. I've had bad watches, and it all comes down to, everyone's wearing a backpack, and is someone standing there throwing more rocks into it, or are we taking rocks out of it? But AI will actually allow us to have a better backpack. It will allow the human at whatever part of it is that can make better decisions. And Nigel's talking about like what's your mission, and whatever mission something, whether it's an uncrewed system that's going to execute, it's being ordered at the end of the day by a human. And so what information does that human have, and how can they deal with that? So when you think of the bridge watchkeeper who's still on a crewed vessel, how can we help that person? And can we tell them specifically, okay, you need to keep all contacts at a certain CPA, so as not to scare other people, and you need to do this within the rules, because this is the way it has to be done. And how do we help people with that, and how are they going to adopt that technology so that it's not one more thing for them to do?
Nancy, I loved your comment about even for the autonomous vessel being commanded by a human somewhere. And I love that, because like we've been alluding to, how we make the data integrate, how we make the decision processes integrate, it is all the same thing regardless of how many people are standing on that vessel. We need to know what's there. We need to be able to consume that information in an effective and timely manner, and then we need to make a decision on the information that we've received. And I think there's a huge opportunity with AI to do a lot of that heavy lifting, taking the rocks out of the backpack as well as making the better backpack. But I think there's also opportunities to demonstrate to us, the people, on these crewed platforms, how can we use these AI tools to show we're adding confidence, we're reducing risk, like the decision support systems that you have in your systems, the capabilities that Robosys offers for their remote operated and also their fully crewed vessels. And I'm really excited about that. At FarSounder, we've recently had a number of patents issued on AI algorithms, and we are just starting a new small R&D project to hopefully take some of those out of the laboratory and put it into our user-facing products. But from my perspective, we already established, Nigel, I'm not as old as you, but I still feel old enough that I am hesitant about jumping all into the fully let the machines run everything. I like to make small steps, and certainly we'll be taking a lot of small steps as a community and as an industry over the next 2, 3, 5, 10 years. So I think we will be there very quickly. But if we can demonstrate, here's how it adds value in the crewed systems, here's how that same approach, maybe a little more complicated, adds value to the remotely operated systems, that will also show the track record of now we can let it just do that autonomously. And I know we're starting to do that with some places, but not every vessel is autonomous or uncrewed for many good reasons, but also many illogical reasons. So there's not just the scientific and technical hurdles, but there's the mental and political hurdles to be crossed as well.
So I would offer up that this is a conversation that is surrounded by the good guys, surrounded by good utility, good, well-meaning applications, great development. That's goes without saying. The defense part of me, the defense legacy that I have, leads me to think, what about when you don't have the good motives, the good guys, the good applications? And there's an awful lot of intelligent misuse or purposeful misuse of technology. So how about if there's purposeful, espionage or infiltration? Matt Wood made a couple of comments in the chat about the trustworthiness of data. Can we speak for a moment to the checks, balances, security, safety aspects that will keep us relying on or trusting our data sources?
Yeah, and I there's so much about that. We have standards for standards, really. There's rules for all the rules in the defense world. And it's a matter of following them, but making sure that they're relevant, because every bit of information that's coming into the ship should be considered as a threat vector. Because, that's what our adversaries are trying to do. They're trying to disrupt and deter people from, operating in areas. But when you see what's happening, especially in the Baltic, it's continuous GPS jamming and spoofing, and it's what at the end of the day, it's sort of that gray zone between commercial and military shipping that's happening there, but also the undersea critical undersea infrastructure. Wow, that is. Is that an act of war? Is this, you can have a whole philosophical discussion, but at the end of the day, there are people, you have to consider that there are people who are actively undermining what it is that we're doing, whether it's information or, systems, that there is an actual threat to pretty much everything that we're doing.
Tom Fournier brings up a comment, and I just want to toss it in here as you continue this discussion. He asked for our thoughts on AUKUS Pillar 2 as an opportunity for standardization, integration, real-world testing across, in this case, the Pacific. But this lends itself to, addressing this topic. And Matt, I think you were going to say something.
Well, I was going to bring up an example from the superyacht sector. I was talking to a captain who was involved in some GPS spoofing research. They brought some researchers on board. This was probably close to 10 years ago now. They brought researchers on board. They told the bridge crew at some point during this transit, we are going to spoof your GPS. And so I don't think you can be any more aware and actively looking for these types of attacks than this crew, because they had the security researchers on board. They told the bridge crew, we're going to do this. They still didn't know when they got spoofed. And that led them to being off track by some hundreds of meters from where they thought they were. And they purposely went to deep water where there wouldn't be underwater hazards, and they were in international waters, so they weren't violating any national sovereignty regulations about this. And so the challenge is going to be not just can we operate in these conditions, but can we identify them? And I think sensor fusion and AI can certainly be tools to help learn to identify it. What we do afterwards is a whole separate discussion, but just identifying it alone, I think, is a big step forward. And obviously in the defense sector, you have trained crews, electronic warfare officers actively looking for these types of attacks. But the commercial and recreational markets, hardly anyone is even thinking about it. So there's challenges there that we can address as well.
Yeah, and if people are in the market for an excellent warship Ectis, that's one of the services that kind of thing provide. I'm just kidding about that, obviously, but that is something that we've always looked at. And in fact, when I was navigating one of our ships, we had morale phones put in, and there was so much interference that every time we plugged in those phones, it would jam our GPS. So again, it's that mistrust of literally everything that is doesn't help me in my day-to-day life, but it definitely helps at sea.
As the threat evolves, so does the solution. So having the software that takes all the data feeds in, working with the likes of perception systems, SEA.AI, forward-looking sonar, to actually cross-correlate that actually we're not where we think we are, etc. That is evolving. That is where money is being put to overcome the P&T challenge, operate in a GNSS-denied environment. I just want to pick up on, was it Tom's question earlier about AUKUS Pillar 2 that you raised, Lee? I think my observation is there's not a demand signal there. We use that quite a lot because for autonomy, particularly in the defence, for the US, definitely seeing the demand signal. Across the other parts of the AUKUS pillar, apart from the submarines, where I'm not seeing, industry has said this several times at conferences I've been to, they're not seeing a demand signal. I think AUKUS Pillar 2, from my understanding, it is potentially at risk. I'm not seeing much around the autonomy come out of that, so I'm not seeing it as an opportunity to standardise. I think, yes, there's definitely a demand signal from US military, Ukrainian and Asian areas, theatres operation. But I think the US have been trying to push for a modular open architecture. But I'm not seeing it across the Five Eyes. Sorry, AUKUS, not the Five Eyes, AUKUS. I'm not seeing that at the moment. Lee, from Navy X, you might have seen something on AUKUS Pillar 2 or not.
It's evolving. It's evolving. And I want to be respectful of our time. We're wrapping up here in about a minute and a half. Is that correct? Do I have that correct? Okay.
It doesn't seem right.
It doesn't seem right. We have teed up a number of other questions just in case, as long as you know in the audience that we put a lot of thought into this, not realizing maybe how deep and rich the discussion would go, which is exactly what we had hoped it would do. So we have time for a very quick lightning round of last thoughts. Nancy.
Yeah, at the end of the day, it's a terrible way to go around things, but you got to trust no one and trust no information and just be exceptionally skeptical.
Yep.
It doesn't make friends, but.
Got it. Matt, in the order on my screen, you're next.
I'm going to counter Nancy with, I am extremely optimistic about how we can move forward. We don't have to be perfect, but we can be better through good, thoughtful integration of the displays, of the sensor fusion, and then also bringing that into decision support systems to supporting the vessel operations, whether they're crewed or uncrewed.
Great. Nigel.
Evolving. The technology is accelerating. the capacity is accelerating, so evolving, and continue to build that trust.
Fantastic. And Philipp.
Yes, I also fully agree what the others said, and I'm really optimistic also about the technology, about AI. I really think it can make a difference. It's now as we get data and we just see them, but with AI we can then talk to technology. It's not like it goes in the direction of agent. So you have really your co-pilot. It makes easier. We go from this rule-based to really that you can talk to your instruments, let's say. So this is really the next step, and therefore I'm confident also that people will adopt it. So exciting future.
Thank you. And I would just add that the opportunity, more so than ever, for dual and multiple use applications across industries, meaning we talk to one another, understand each other's hopes and challenges and restrictions and missions. A time for expansive frontiers while looking at guardrails and using common sense. Thank you to everybody. Philipp, Nancy, Matt, Nigel, great discussion. We could go on for hours, but this has been a very rich discussion and opens a lot for the consideration. Thank you.
Thank you, Lee. Thanks, everybody.
Thank you, Lee. Thanks.
Bye-bye.
Thanks, everyone.